Hello everyone, welcome back. Today we'll be solving one more lead code problem, that is minimum time to make rope colorful. So let's read quickly understand the problem. I'll be not reading this statement because uh, I'll be explaining that. That's why. So let's quickly see the first example and I will explain you each and everything about this problem. So we have given two things. One is a string of colors and one is needed time. So we have a rope and we have some balloons tied over that rope and they are of various colors. And we have to do one thing. There are two person in this question. One is Bob and one is Alice. So Alice has tied all these Bob has tied Alice has tied all these balloons on this rope. And but now Alice needs the help of Bob, and what Bob should help with. Now Bob should come and remove some balloons from this rope so that no two consecutive balloons should have the same color. If you can see in this example, these two blue balloons are of same color, and Bob has removed one. And now Bob has removed one, then which one to remove out of these two? So for that, we have given this array needed time. Okay, so I'm not thinking this as a time. I will consider this as the cost. Okay, so suppose each and every balloon is associated with some cost. Like the first balloon is of 1 rupee and second balloon is of 2 rupee. That way we can understand the problem more better in a more better manner. That is the only objective of considering this needed time array as the price of these balloons. So we don't want to remove the expensive balloon. We want to remove the cheap balloon because we don't want to throw something out of our house which is expensive, for which we have spent more money. So that's why out of these two balloons at index second and third, that is 3 and 4, I will remove the one which has less cost, that is 3, the balloon at index 2. So I will remove this, or the Bob will remove this rather, and then our string or rope will look like this. And we just have to remove that what is the total minimum cost it will take to make this the entire rope colorful. So in this case, they have removed only one balloon that was of 3. So the total time it is 3. Why it is time? Because in the question, uh, it is saying that it is said that it is taking some time. Bob will take some time to remove the balloon. So maybe the knots were so tight for this balloon. That's why we are not removing the balloon. This one is also good. Uh, we can consider that the balloon which has more knots on it, so it will take more time. So we will not uh, remove that balloon which has more knots. We will remove the balloon which can be removed easily. So we can think this needed time in that manner. Okay, so now I've given two examples. Now let's go to the pictorial explanation, and with that, I will explain the algorithm also, that how we'll be solving this problem by the help of the code. Okay, so the this is the rope where we have these balloons tied, and on the top of this I have there is some number written over it, that is needed time, and how much time it will take to remove this particular balloon. So the first balloon, if you want to remove the first balloon, then it will take 1 minute, or it is saying cost, so it will take uh, one as the cost. Similarly, it is written on the top of every balloon. Now I will iterate over this string from left, and I will check that whether my current balloon is same color as the previous balloon. Fine. So I will be start iterating from this point, from this point. Okay. So I will check at this point that whether my current balloon is same as the color as the previous balloon. Currently, my previous balloon is this. So at my previous, where my previous balloon is, I will write P here. Okay, fine. So they are not same, they are different. So fine, if they are different, then I will, what I'll do, I will move my current to the next index, and I will move my previous to the next index. Okay, fine. Now I will check they are again different. So in that case also, I will move my current to this place, next index, and I will move my previous to the next index. Fine. Now life is going so smooth till now. Now the problem has come. We have found the balloons with the same color. Now which one to remove? So to remove this balloon, it will take 7 as cost, and to remove this balloon, it will take 5 as cost. So it is pretty simple. We have now got that we have to remove the balloon with the less cost. So we will remove this one. So we will remove this from here, and I will put this somewhere here in the down. Okay, fine. So after doing this, now where to move this previous? So my previous will remain here only because the next balloon is this, and my previous will remain this balloon at this index only. Fine. And I will move this current to the next index. And I'll check, oh, again, after removing this balloon also, I have the consecutive balloons as of same color. Again, this is a problem. Now I will check which one to remove. Again, I will remove the one with the less cost. So this one is with the less cost. I will remove this one. I will take this from out, and I will keep it aside. Fine. Now my pointer, this current will again move to the next spot here. Fine. Now I will check that my previous and current is same or different. So they are different now. So they are different, then my previous in this case will be updated, and my current will be this, and my previous will get updated because I found the colors which adjacent colors are different. Okay, now let's move forward. Now I'll move my pointer to the next element, and that is green balloon, and I'll check whether the last balloon is same or not. So last balloon is this, and is this same? No, this is not same. So okay, I've already compared. I have not told to compare these two. So these two are also different, and I will move my current pointer to here, and I move my previous to the next one. Fine. Again, these are different. So again, I will move my current to next, and my previous to next. Fine. Now they are of same color. They both are green. Now in this case, again I will remove the one with the minimum cost. So this one is minimum cost. So in this case, you will see I have removed four. I've removed four from here. Okay, fine. Now, what will happen to my previous? My previous should get updated to the current now. Now it will come at this point. So, because I'll move this to the next one. When I'll move this to here, my previous will be this. It will come here. So again, these two are same. So which one to remove? I will remove this one with the less cost. Fine. And my this will be move here and my previous will remain here only. So you have seen if the current element is getting removed, then I am not moving my previous. Why? Because that is already more than the present element. So now you can see this entire rope is colorful. No two balloons are of same color. And what is the total cost of making it colorful? It will be 5 plus 3 plus 4 plus 3. That will be 15. So we will return 15 as our answer. Now, how we will be doing this in the code? Let's see on the editor. Okay, so let's quickly code this. So to do this, I will take one variable as cost, and it will be zeroest in the beginning. And I will be taking one previous, and that previous will be a needed time of 0. So instead of needed time, I will convert this as time. Okay. And let's do this as curl. Okay. It will be easier to now code. So time of 0 initially will be our previous. Now I'll run a for loop beginning from I equals 0, not 0. Why not 0? Because I have already told you if I'll begin with 0, then I don't have any previous element. So I will be starting from the first, and I have already stored the uh, value of uh, the 0th index in the previous. Fine. So I less than uh, color dot length. It will be with brackets. Okay. And I plus plus. Fine. So now after doing this, my first task is to check whether the current balloon, the balloon at the current index is same as the color with the last index. So I will check with the last index. So for that, I will put a check here. If uh, color dot char at I equals color dot char at I minus 1. Fine. So this char at I will be uh, fetching the value at the current index, and this char at I minus 1 will be fetching the value at I minus 1 index. So if I is 1, then I minus 1 will be 0. So this balloon at first index is being compared with the balloon at the 0th index. So if they are same, then only anything will happen. Otherwise, I will have some else case. So if this will happen, then fine. Otherwise, I will do uh, something in the else statement. So what will I do when I find these two balloons as same? So if they are same, then I need to remove any one out of these two. So which one to remove? So I will take as item int. I'll write it as let's say item removed will be which item will be removed. It will be math dot min of the one which has the less cost. So how will I get that? Either it will be previous one or it will be current one. So let's write current. I'll take current here. So my current will be time of I. Fine, fine. It will be current. Looks good. So this will be so this variable will have the cost of the item which has got removed. So item will be removed minimum out of these two, whether it will be last or it will be current. Fine. Now I need to add this to my cost. So I will put this item removed here. Fine. And after doing this, I need to update my previous also. So what will be my previous now? What will be my previous now? So my previous will be the maximum out of current and previous. Is it so? Because I have, suppose I have, let's see in the example. So when I remove the 5 from this place, when 5 was here, let's let's put this 5 here. Okay. So when 5 was here and I removed, which one I removed? I removed my this 5 from here. Okay, that is the current element. So after removing this, so when I removed this, what was the current? Current was 5. What was the previous? Previous was 7 at this point. And I removed this. And what my previous will remain? Previous will remain the max out of these two. And what will be the vice versa condition? When I removed, uh, when I removed 3 from here. So let's understand both the cases. We could have two cases. Let's put it here. Okay, fine. So when I removed, my previous was here. Okay, fine. And let's see. In this case, I removed 3. Why? Because the value of 3 is less than 7. So I updated my previous to the 7. Why? Because this has got removed. Now my next element will be here. If it is 1 or anything, it will be here, and my previous should come logically here. So if I'm removing this, then if I'm keeping this, then there must be some logic, and the logic is very simple. The least of these two will be removed, and the max of these two will be kept as the uh, previous. So that is the logic I'll be using inside the code. Here also, my previous, after removing the 5, my previous 7 will remain the previous. And after removing this 3, this 7 will become the previous. So in both the cases, the maximum of the 2 will become the previous. Maximum of the 2 will become the previous. And in both the cases, the maximum is 7. So that's why we are writing the condition that previous will be updated as the maximum of out of the two, that is current or previous. Okay, so I hope this is pretty clear. We will compare the current element and the previous element, and we will update the previous to the maximum of the current and previous element, because we are removing the minimum element. Minimum element we are removing, and we are updating our previous to the maximum element. So let's get back to the code. So my previous will be math dot max current comma previous. So it will automatically take the maximum out of these two. And if they are not same, if the balloons are like this thing, then we need to simply update our previous. So what will be our previous? It will be equal to the current. We'll keep on updating the previous to the current. Fine. So this is the code, entire code. Yeah, done. Only one thing remaining. We need to return one value from here, return the cost, and this is done. Now let's run this code. And it has got accepted. And let's submit this. So what is the time complexity of this code? So the time complexity is linear, that is big O of n, and it is got accepted. So for, you can see the size of the input. So the size of the input was from 1 to 10 to the power 4, and needed time was needed time I was 10 to the power 4. So you can uh, think that the better solution will be the linear solution. So we have got the linear algorithm. Now this is it about this code. Explanation is done, submission is done, everything is done. Now one thing is remaining, that if you like this video, then do share with your friends, and subscribe to the channel. It is very important. Subscribe to the channel, and so that will motivate me, that will encourage me to create more videos, and I will put more effort while making the videos. And that's it. Till then, keep learning, keep growing, and I will see you in the next one. Bye bye.